Let us just recall what is a sequence and a series. So when we say a sequence, we mean a list of things or objects arranged in an order. So this list of thing or object, it can be anything. It can be living things or non-living things or any kind of objects. So when we arrange this list of things in an order, that means we arrange them in such a way that we have the first, second, third, and so on. Then those list of things or object we call a sequence. So for example, we can take the things or objects to be numbers. So 1, 2, 3, 4, and so on. So this is an example of a sequence. So now whenever we have a sequence, right, say in general, say A1, say A2, A3, then A4, and so on, then we add this list of objects which is arranged in an order A1 plus A2 plus A3, say up to AN, then this sum we call it a series. So now in this session we'll be uh, focus on one sequence or what we call progression. So let me just define first what does it mean when we say progression. So after we have a sequence or we have a list of things which is arranged in an order, then that sequence, if it follows a sequence, is called a progression if it follows a specific order or rule or pattern. So we have three types of sequence. So the first one is arithmetic progression, or in short we call it EP. Then the second progression we call it geometric progression, or in short we call it GP. And the third progression we call it harmonic progression, or in short as HP. So in this session we'll be focused mainly on this second types of progression or what we call GP. So let us see what is a geometric progression, or in short GP. So as we have seen earlier, a geometric progression is a sequence. So let me uh, write first the definition. A sequence. So let us denote the sequence as say A suffix 1, A suffix 2, A suffix 3, and so on up to say AN. So this sequence is called a geometric progression if it satisfies this condition or this rule. You take any term and then divide by the preceding term. So if we take the second term, so divided by the first term, or we take the ratio of any term with the preceding term. So first with second, second with first, then third with second, and so on till you reach the last term, and then with the term before the last term. So if each of this ratio is equal to a constant value, say we call it or we denote it as R, then such a sequence is called a geometric progression. So where this common value R is called a common ratio, right? So this is the definition of a GP or geometric progression. So now let us deduce how to find the general nth term of any GP. So general nth term of GP. So let us denote the first term, which we denote in this definition as A1, to be, say, simply A, and the common ratio to be R, as given in the definition. So now if we use, so now let us take, say, now by definition we have what, A2 by A1, so this ratio is same as A3 by A2, so this is same as A4 by A3, then and so on, so till we reach the last term, that is an by an minus 1 is equal to R. So if we take, so therefore that means A2 by A1, so this is R. So if we simplify, so this is A2 is equal to A1 R, so which implies A2, that is the second term, is equal to A1, that is the first term, which we denote as A, then R. So this is your second term, or our second term. Now if you take the second ratio, that is A3, so similarly A3 by A2 is R, so this implies your A3, that is your third term, will be A2 R, so which implies A3. But what is A2? A2 from here is, so in place of A2 we can write AR into R. So finally we have A3, that is the third term, is A, then R into R, so it will be R square. So if we look at this pattern, okay, we can see something. So let us take one more ratio, that is A4 by A3. So this is R, so which implies your A4 is A3R, so which implies A4, but A3 is AR square. So finally we have at A4, that is the fourth term, is AR to the power 3. So now let us compare each of these, or let us just observe at each of these terms. So now if it is A2, second term, AR, third term, AR to the power 2, fourth term, AR to the power 3. So now we see that uh, the power of R, in each term we have E, but the power of R reduced by 1. See, if it is 3 here, then the power of R is 2. If it is 4, the power of R is 3. So if we continue in this way, then finally we have the nth term. So finally, so let me write, so continue in this manner, we have what, an, that is the general nth term, is equal to A, then R, then decrease the power of R by 1. So this is the general nth term of GP. So this is the first result, or the first formula, which help us to find any term of an AP, provided we know the first term here and the common ratio. So next, let us see how to find the sum of the first n terms of GP in general. So let us denote the sum of the first n term as S suffix n. So this is A1 plus A2 plus A3 up to the nth term. Right? So that is Sn. So now if we replace this, so A1 as A, then the second term will be AR, third term will be AR square, then the last term, that is the nth term, will be AR to the power n minus 1. So let us denote this by 1. Now we multiply by the common ratio both sides. So this implies R into S suffix n. So now first term multiplied by R will be AR, and the second term when you multiply by R will be AR square, plus next will be AR cubed, plus then the last term will be AR to the power n. So we take this as 2. So now depend on the value of R, whether R is greater than 1 or R less than 1. So if R is greater than 1, then each of this value will be greater than the value here. That means the first term will be greater than the first term in equation 1, the second term will be greater, and so on, or the corresponding term in the second equation is greater than the term in the first equation. But if R is less than 1, then each of this value will be less comparing to the value here. So now let us take the case R greater or R less than 1. Let us take the first one. Then we subtract this 1, that is equation subtract by 2. So we have in the right hand side, left hand side, we'll have what Sn minus Rsn. So now 1 subtracted by 2, so this will be subtract by this, so all the term will get removed except the first term and the last term, that is A minus AR to the power n. So now we can take common Sn here. So 1 minus R inside bracket. So the same thing from right hand side, we can take common E, and 1 minus R to the power n. So therefore Sn is equal to E of 1 minus R to the power n, then whole thing divided by 1 minus R. So this is the sum of the first n term of an AP if the common ratio is less than 1. So just to make a note here, so in some cases you will see that this Sn is also denoted by summation of AR. R goes from 1 to n, which is equal to E of 1 minus R to the power n, and whole thing 1 minus R. Then the second case, if your R, that is common ratio, is greater than 1, so the same way now we'll just subtract in the reverse. So 2 minus by equation 1, then you'll have an Rsn minus Sn. So here will be A to the power n minus A, because now the same thing, all the term in between, between the first term in equation 1 and the last term in equation 2, so all those two will get cancel. So which implies that r minus 1 whole thing of Sn. So this will be e common, then r for n minus 1. So therefore Sn is equal to e, then whole thing of r for n minus 1, then whole thing divided by r minus 1. So just the reverse. If r is greater than 1, so here we have r minus 1. If r is less than 1, just the reverse, 1 minus r. So this is the formula which help us to find the sum of the first n term of a GP.